Hello guys, so we'll just start a class. Give me a moment, let me just check our network, our audio and video, if they are functioning perfectly fine. Just give me a moment guys. Hello. Yes, it's functioning fine. Now we can start our session. So we'll wait for a minute, let people come, then we would continue with our lecture. Meanwhile, if anyone is having any doubt, you're always free to ask. Okay guys, so we'll start our lecture. So hi guys, I welcome you all in Let's Crack J in English, and today we'll be delivering complex number 4, lecture 4 on complex number. So those who are joining me the very first time, so this is a small introduction. Hi, I'm Nishant Khanduja. I graduated and post-graduated from IIT Bombay. My rank was in IIT, it was 1256, in AIEEE it was 363, in Rajasthan pre-engineering test the all India rank was 4. I traded in US and Canadian markets before I started teaching, and I have almost 8 years of teaching experience. And one thing which is not mentioned here, which is something really close to my heart, that I want to give education to people, those who are there in small cities, villages, those who can't go to coaching institutes for the preparation of these competitive examination like JEE. So I want them to teach, I want them to share my experience. I want to share my experience with them. I want I want them to have the knowledge what I have gathered through my observations, through my hard work. So I just want to share that guys, you can prepare for the competitive examination like IIT JEE if you don't go to coaching institute. You can still do that. So that's my main motto. And with the same thought process, I ended up joining Unacademy with their largest campaign, that is Crack IIT JEE. Here I'm doing a small part, and my small part is I am teaching you guys mathematics for IIT. Now this is my part. Now what you need to do? You need to install Unacademy Learning app. Once you do that, you get two options. One, plus subscription. Another one is iconic subscription. So before starting from me, so you need to subscribe either of these two packages. So let's talk about this plus subscription. So the benefits of this plus subscription is you get to have daily live classes. So these daily live classes are completely different from your YouTube live classes. The kind of experience you are going to have here, it's next to offline classroom experience. This is what I say, because you can chat with, you can interact with the educator, you can just engage with him for the questions, for the doubt sessions. You can also be a part of polling system. You can just attempt live testing quizzes. You can evaluate your preparation. You also get to attend structured courses by all these top educators. So in the shortest time span, you can gather maximum knowledge. You also have the unlimited access to the recorded videos. So wherever you feel like, n number of times you can watch these videos and revise your topics. Whereas in iconic subscription, these plus benefits are already there. Apart from that, you also have personal coach, personal mentor. So this personal mentor will be working very closely with you. He would be the person who knows your assets, shortcomings. So he would be the person who would be telling you that how to strategize for the examination, what you need to do, what you do not need to do. You also have test analysis report that would tell you that how you can manage the time, how you should approach the examination, how you can save your negative markings. We also have study planner that customizes the study according to students' need. It also reviews your progress bi-weekly. If at all there are any changes, it suggests you to incorporate them so that it tries to deliver better result for you. So this is your iconic subscription. When it comes to buying these packages, you have options for 6, 12 and 24 months. I always suggest if a student is there in 11th standard, he must go for 2 years package. The reason is very simple. So one of the reasons could be that since it's a 2 years preparation, so no one would like to discontinue his or her preparation before the examination gets over. First. Second one is, since it's a 2 years preparation, so all the educators, they have planned, they have designed the curriculum in such a manner that during this time span you can cover up all the topics, having with enough time, with enough practice. So if at all you tries to discontinue it in between, you might end up skipping a few topics, which would result into bad results. So no one would like to take a risk. Third one is, it's very cost effective. Look at the price. The price is 2,333 rupees per month. So if you just look at per day price, it turns out to be what, 78 rupees per day, which is nothing, which is actually lesser than nominal price. And this is what you are paying to India's top educators. So for 2 years, what you need to pay is 56,000 rupees, and this reduces to 50,400 rupees. Given the fact, if you apply my code NK001, people those who are there in 12th or dropper, they must go for 1 year package, that is 38,500 rupees. It reduces to 34,650 rupees if you apply my code NK001. Okay, for iconic, the price becomes 86,000 for 2 years, and it reduces to 77,400 rupees if you apply my code NK001. For 1 year, it is 56,000 rupees. It reduces to 50,400 rupees if you apply my code NK001. Okay, guys. So this is what you need to do if you want to learn from India's top educators. You can just subscribe these packages whenever you feel like. There is no rush. But as a as an elder brother, I can suggest you one thing, that is, go for these packages as soon as possible, because already courses are being run. And when this is happening, so for the preparation, you would like to have enough time. You would not like to join in between and then find yourself nowhere. It's better you join from the scratch. So since a few courses they just lately started in September month, in October month, and a few are about to start, so it's better you join or subscribe these packages ASAP. Okay, guys, so this is a suggestion from my end. Now we would start our class. So where we left, the last class, we did this conjugate thing. We also did this mod thing also. Yes, this is the question I gave you in the homework, right? So we'll start from here. Okay, guys. So we'll start from here. So what it is, it says that Z1 and Z2 are two complex numbers where sorry guys, it just, okay, give me a moment. My phone, yes, because I need to see you guys leaving comment, so I have to respond to that also. Okay, so Z1 and Z2, these are two complex numbers where U is what? A complex number which is square root of Z1 Z2. Then we have to prove that mod of Z1 plus mod of Z2 is equal to this: mod of Z1 plus Z2 by 2 plus U plus mod of Z1 plus Z2 by 2 minus U. Okay, so we need to prove that. So now tell me, how would you approach? Will you start from the left hand side or right hand side? See, I would suggest better you start from the right hand side, because right hand side is bigger side, and just trying to simplify, trying to just make it smaller form, that is still possible. But expanding this, the left hand side, this might become problematic for you. So better we start from the right hand side. So let's start from the right hand side. I'll substitute U This is what I have. Now, just look at this. What is this? It seems like as if it's a square of root of z1 plus root of z2, right guys? By, let's say, root 2. So I'll bring it to the bracket. Okay. Now this is what? Root of z1 minus root of z2 by root 2's whole square. Correct? Now, what we can do is, there is one property, if you remember, that mod of z square can be written as z square mod also. I hope all of you remember this. If you remember this, so this thing can be written as z1 plus, do we need to use this? Yes, let's use this. This can be written as the conjugate of these numbers, the inside numbers. So bracket root z1 plus root z2 by root 2. Then conjugate of this, right? Similarly, this term will become like this. Now let's multiply. When you multiply, see what you'll get. I'm doing it here. So when you multiply, so you'll have root of z1 into root of z1 bar. So this bar can come inside, right? So eventually what will I have? I'll have z1 only, mod of z1. How? Because what do we know? We know this thing, that if conjugate, two complex numbers both are conjugate to each other, so when they multiply, so what do we get? Mod of that complex number square. So square will cancel out the square root here by 2. Similarly for z2 also, minus, then we have what? Root z2 root z1 bar by 2 plus z1 plus, sorry, into z2 bar by 2, and minus root z2 into root z1 by 2 minus root of z1 into root z2 bar by 2. So this term, this term, this term, everything will cancel out. So only the remaining till, yes, we will have this term also, remaining term from this second term. Now you can add both of them. When you add both of them, what will you get? Mod of z1 plus mod of z2. So here is the proof. That's it. It's a very easy question where most of the properties of conjugate and mod, they are being used. So you can just solve this question. It's a very good question just to check your basics. Fine. So let's move ahead. I hope you guys must have solved this question. Now let's solve this question. Now here A is angle and it is between pi by 2 to 3 pi by 2. So basically second and third quadrant. So A is between second and third quadrant. Then you have to find the modulus and argument of this. So check. So sine of 2 alpha. If I just check, let's wait for a while, then we'll talk. So what I'll do is, first I'll write down, I'll simplify this complex number. So 1 plus cos 2 alpha can be written as twice of cos square alpha plus twice of iota sine alpha into cos of alpha. I can take twice of cos alpha common. So I have what? Cos alpha plus iota sine of alpha. Right? Now, this looks like an Euler form, right? and this can work as a mod, right? So if I want to write the mod would be what? Modulo of z. Let's say this is z. This is what? Twice of cos alpha. And as we know that alpha is what? Okay. So one more thing I would like to suggest, just discuss with you guys. When you apply mod, because we need to make it positive. When we need to make it positive, because see, look at this. This a is varying between what? Second to third. So in second to third, our cos is what? Negative. To make it positive, I'll have to apply minus sign. I hope you got this thing clear. Now let's check this. Cos A, so cos alpha, let's say this, I'll make it alpha. So cos alpha plus iota sine alpha. Okay, so this is an Euler form. Now look at this. When this is an Euler form, so the argument is it is clearly seen that argument of z is what? It's alpha only, and alpha is varying from varying from pi by 2 to 3 pi by 2. So now we have to just take care. So what I'll tell you what we need to do. First, I would suggest let's not write this for a while. The reason I'll make you understand, because why I'm doing all these things, step by step, because these are the basics questions you have to always ask to yourself while you are solving question. Can you write it? Because I know you would directly write alpha, but see, your alpha, the argument of any complex number varies from minus pi to pi, right? Now just imagine if your a or your alpha, let's say if your alpha is there in second quadrant. So if it is there in second quadrant, so I can write it as it is. I do not need to make any sort of changes. So I'll say if a is in second quadrant, so this a will be argument of z. There is no problem with that. Okay, because that will be the absolute value, which is completely fine, because your sine alpha will be positive whereas cos alpha will be negative, which is completely fine. But if this a is in third quadrant, so now tell me what will happen to the argument of z. So in third quadrant, both the cos alpha and sine alpha both will be negative. If both are going to be negative, what will you see? See, both are negative. When you will be taking the argument of z, so argument of sine alpha upon cos alpha negative will become plus. You will be getting some angle in here in first quadrant, as if, because tan inverse, the absolute value of tan inverse when you will be getting it, whereas eventually the argument is somewhere here, and whereas someone has calculated a like this. So how to write this angle? Tell me guys, how would you prefer writing this angle? Any suggestion? Okay, so one way how you can write it, so as you know, this is going to be there in the third quadrant, right? But you have to make sure that it remains between the argument remains between minus pi to pi. Okay, so if you want to measure it, let's say clockwise, so how would you measure it? So if someone has measured it like alpha a, so you would prefer measuring it like minus pi, no, not at all, not that place. So 2 pi minus a. If you do it 2 pi minus a, yes, you would get the same answer. Now you might say, how did I get this answer? It's very easy. Okay, just try to understand this thing. So what am I going to do is, I am measuring it like this. This is a. So I have to go the clockwise, in the clockwise direction, and I have to make sure that I get the same angle. So what I'll do is third quadrant, right? So see here, if I write something like this, sine of minus 2 pi plus a. Okay, so minus will come out. So I'll have what, minus of sine 2 pi minus a. So minus of sine of a I'll have. Why? Minus minus will become plus here. So plus of sine a. And I know a is in third quadrant. So by default, I'll get the same answer. So as you can see, in both ways, I'm getting the same answer. So here, argument would be what? Minus of 2 pi plus a. I hope this is clear with everyone. So in this case, you would be getting negative. Shall we move ahead now? Okay, let's move ahead. And here, as you can see, the argument will always be in the third quadrant. You just put the value of a. Just imagine if you can put 210. When you put 210, what will you see? Your angle will be minus 150, and minus 150 will be still the same. 90 and then minus 60. I hope this is clear with everyone. Okay, guys. So shall we move ahead now? Okay. Now the question is root of 8 plus iota raised to 50 plus, so is equal to 3 raised to 49 into a plus iota b. Then you have to find the value of a square plus b square. Now the thing is, we have to find our a square b square is what? It seems as if we have to find the magnitude of this a plus iota b. So in other way around, I have to just take this 3 here, 3 raised to 49 here. Then only we can just find a plus iota b, and then we can calculate the magnitude easily. So let's do this way. A plus iota b will be equal to what? Root of 8 plus iota raised to 50 upon 3 raised to 49. Now, if I try to write this in Euler form, so mod will be what? Mod will be r, so 8 plus 1 into, so I'll have what? Cos of angle. So instead of angle, what I'll do, I'll directly write the argument. So it will be e raised to iota 1 upon root 8. Clear? Raised to 50. And when we have taken this out, so this will be what? 50 as well, upon 3 raised to 49. Now this is what? 3. So 3 raised to 50, 3 raised to 49. So finally what will I get? 3. E raised to iota 50 times root 8. Here. Now what do I need to calculate? Oh, I need to calculate a square plus b square. So this is what? A plus iota b. So that means someone is asking me to calculate a square plus b square. And root of a square plus b square is what? Basically the mod of this number. So if I want to calculate a square plus b square, what do I need to do? I just need to square it. So if I square both the sides, so a square plus b square will be what? That will be equal to 9. Get it, guys? I hope everyone got this question. That's not a difficult one. It is just the conversion between the forms. That's it. Shall we move ahead then? Okay, guys. So let's move ahead. Now there is a slight change in the question. It is z raised to z4 and this is z2. I think it's z3. I think it's 3. I'll erase it. It's 3. Okay, so let's read the question here. If z1 and z2 and z3 z4 are two pairs if of conjugate complex numbers, So that means Z1 is equal to what? Z2 bar. And Z3 is equal to Z4 bar. Then we have to find the value of argument Z1 by Z3 plus argument Z2 upon Z4. So what we'll do in this question is, as you know, argument addition is happening. And argument addition happens only when we multiply two complex numbers. So addition of these arguments, these two complex numbers are being happening. So that means we have to eventually find out argument of Z1 into Z2 by Z3 into Z4. Now as you can see, this, what is the argument of Z1 and Z2? So there is a very standard relation. If two conjugate numbers are there, so then the relationship between their argument is what? So argument of Z1 will be equal to minus times of argument of Z2. Why? Because both are conjugate to each other. That's why. If that is the case, let's say if I use the Euler form, so e raised to iota theta 1. So this Z2 is what? It is basically the conjugate of Z1. So e raised to minus theta 1. Similarly here also, I will be writing e raised to iota, let's say theta 2. I know that Z4 is the conjugate of Z3, e raised to iota minus theta 2. Now as I can see, so argument of e raised to iota 0 upon e raised to iota 0, what will I have? Finally I'll have argument of a real number, right? Because this will also give me real and this will also give me real. So eventually I'll be getting a real number because I'll have mod of Z1, mod of, I'll write it for you guys because I know people might get confused, so it's better I write it here. People should not get confused, so that's the first motto. So here we'll have what? Mod of Z1 square upon mod of Z3 square, because after all they are conjugate to each other. So when conjugates are being multiplied, so what do we get? Mod of conjugate numbers square. So we'll have this only. Now real, so argument of real number is what? Argument of real number is always what? 0. It's always 0. So I hope everyone got this question. This is not a difficult question, this is the easiest one. It is just one property of argument is being used here. That's it. Now we'll move ahead. Now we have this question. So there are three inequalities given and they have this relation that mod of Z1 minus 1 is lesser equal to mod of Z2 minus 2, lesser equal to Z of 3 minus 3, lesser equal to what? 3. Wait, there is one more thing missing, that mod of Z1 minus 1 is lesser than 1, mod of Z2 minus 2 is lesser than 2, and then mod of Z3 minus 3 is lesser than 3. Then we have to find the greatest value of mod of Z1 plus Z2 plus Z3. So when we read this question, the very first thing which comes into my mind is, because I have to use this relation, mod of Z2 minus 2, Z3 minus 3. So how can I make these sort of things here? Then I realize, why not? Can I do this? I can write it like this also. Right? I can do this. When I can write like this, so I know one property, that triangle property, if you remember, this is always less or equal to what? Separate addition of the sides. So I'll consider, let's say this is one side, addition to the another side, then addition to the third side, then we have fourth side. Now I know one thing, that this mod of Z1 minus 1, this has maximum value what? 1. So let's put it here. So this will be what? This will be lesser equal to 1, then 2, then 3 plus 6. So finally what will I have? I'll have this as 12. So the maximum value this can have, which is this only, this can have what? Maximum value as 12. Easy question. It was more of a manipulation. When you see the question, you just realize what to do, what not to do. Got it, guys? So these were the questions based on modulus property of the complex numbers. Oh, we have got one more question. So now see, mod z1, mod z2, mod z3 equal to 1. So all three vectors, they have same magnitude. So one vector, another vector, and third vector. All of them are having same magnitude. It is also given that z1 plus z2 plus z3 is equal to 0. What does that mean? If there is linear term in three vectors, that means they are coplanar. The third vector can be written in terms of what? The addition of two vectors. That's what it means, right? So what I mean to say is they can form a triangle like this: z1, z2, z3. So if that is the case, all three of them are equal. If that is the case, so we are getting what? An equilateral triangle. So then we have to find the area of the triangle whose vertices are z1, z2 and z3. Oh, so area of equilateral triangle, what it is? It is root 3 by 4 a cube. So a square. So a square here is what? It is given to us. The side length is what? 1. So the answer would be root 3 by 4. So correct option is B. That's it. We're done with the question. I hope everyone got this answer. Clear? So these were our homework questions. So I just hope everyone should have done all these questions. Now this is a new question which uses a bit of geometry. So let's see this. The question says there is a general number, random number z, that is x plus iota y. It's a complex number where x and y are real numbers. Okay. Let A and B be the sets defined by A. So A is a set where we have all these numbers, and all these numbers are between this. Now what it is? Mod of z is lesser or equal to 2. If you can't imagine it, so what you can do is, as you know that this is the number, put the modulus of this number. This is lesser or equal to 2. It seems like as if someone is talking about a circle whose radius is 2, and it is talking about all the points inside this circle. Okay. Now we have got another set, another point set where z is like this, which satisfies this inequality. So 1 minus iota z plus 1 plus iota z bar. Oh, it seems like as if it's an addition of two complex numbers. Those are conjugate to each other, right? See, 1 minus iota z is what? Conjugate to 1 plus iota z bar, right? So addition of two conjugate numbers are what? Twice of real part of complex number. So let's do this. So first 1 minus iota into x plus iota y. Let's calculate the real part. So 1x, and then we have minus iota square. So minus iota square is what? Plus 1. So we have this. So this is our real part. So twice of x plus y greater or equal to 4. So what do we have? X plus y greater or equal to 2. Here. So what it is? It seems as if this is a straight line, and which is having intercept 2. X and y intercept both are 2. So this line is passing from here, and this has all the points which are there, which are above this straight line. So we have all these points like this, correct? Whereas in circle we had all the points inside the circle. So the common area, common area would be what? This blue area, which is enclosed by this circle as well as this straight line. Now we have to calculate the area of this blue part. Very easy. So how can we calculate? So first we can calculate the area of this section of circle. As you can see, it is the fourth section of a circle. So area of circle is what? Pi r square by 4th. Now from this we have to just reduce this triangle's area, right angle triangle's area. What it is? Half into base into height. So this is what? pi minus 2. That's it. This is your area, pi minus 2. Done. Okay guys, so let's move ahead. So these are very easy questions. It's just we need a bit of geometry knowledge. That's it. You can't call them complex numbers question. It is using basic operation of complex numbers. Okay, we have one more question. So see what it is here. It is given that z plus 1 upon z is what? Twice of cos of alpha. Then we have to prove z raised to 2n minus 1. Then into z raised to 2n plus 1 will be equal to mod of tan n alpha. So what I feel is, while solving this question, that we should first find the value of z, because once we know the value of z, then it will be easier for us to put it here and solve it. Okay. Z square minus twice of cos of alpha z plus 1 is equal to 0. Clear? Now when you calculate, what will be z? Z will be twice of cos alpha plus minus root of, when you put 4 cos square alpha minus 4. Oh, so you can take minus common, so you'll have iota here. So finally what will you have? And you can take 4 also common, so you'll have 2 common, 2 outside. So I'll just erase it and I'll rewrite this just to save space for us. 1 minus cos square alpha. So 1 minus cos square alpha can be written as what? Can be written as what? Sin alpha after taking the square root upon 2. So final answer would be what? Cos of alpha plus minus iota sin alpha. So it seems like as if this is one root will be e raised to iota alpha, another one will be e raised to minus iota alpha. Clear? Okay. Now one thing, okay, I think there is a one change in the question. It is divide. It is divide in the question. So when you try to calculate the magnitude of the inside complex number, so see z raised to, so I can write it directly here. So e raised to iota 2n alpha minus 1 upon e raised to iota 2n alpha plus 1. So one way is obviously I can write cos of 2n alpha plus iota 2n iota sine 2n alpha minus 1, then I can solve that. But before that I thought, yes, one thing I can do. If let's say I divide both numerator and denominator with this e raised to iota n alpha, I divided. I have this term here and I have one term here. When I do that, what do I see? I see as if someone has written what? That addition of conjugates and subtraction of conjugate. If that happens, what do we get? We get twice of iota imaginary part of z, complex number. So imaginary part of this is what? Sine of n alpha. And from here twice of real part of complex number. 2 will cancel out. So when we try to calculate the mod of this iota tan alpha, it's a purely imaginary. So mod will be what? Only tan of n alpha, and it should be positive. So that's why he kept the mod sign. You can prove it for minus iota alpha also, you'll get the same answer. Okay? Here guys. So you can also, if someone has not thought about this, dividing by e raised to n alpha, iota n alpha, you can still solve it. So in that case, you have to write cos of 2n alpha minus 1 plus iota sine of 2n alpha. So you have to rewrite this as what? Any idea? So minus of 2 sine square n alpha, like this. And this you need to expand. Iota 2 sine n alpha into cos n alpha. Then take sine n alpha common. Take both numerator and denominator common, sine n alpha, that will cancel out. Then you will have another form of Euler form. So that's it. So in both ways you can still solve it. It is just I wanted to save time. I wanted to use properties more instead, just solving via simpler methods. Via simple calculations. I prefer using properties so that I am through with all the properties and I can use them while solving objective questions also. Here, let's move ahead. Okay. Now look at this question. It's a very good question. So mod of z is what? Less or equal to 4. So basically again what? If you see it, what it is? X square plus y square less or equal to what? 16. So it seems what? As if someone has made a circle having radius 4. Okay. And it has got all the points inside this circle. Radius 4. Now what it is? If mod of z is less or equal to 4, then we have to find the maximum value of this. Now what it is? It seems like as if someone is talking about the distance of this general point x plus iota y general point from the another point. Let's calculate that point also. So iota or x plus iota y into iota plus 3 minus 4 iota. So this can be further written as iota x minus y plus 3 minus 4 iota. So this will be what? X minus 4 iota and minus y plus 3. So if I take the mod, what will I have? I'll have x minus 4 whole square minus y plus 3 whole square. So it seems like as if someone wants to calculate the distance of point x comma y. So x comma y point is what? Any general point either on the perimeter of the circle or inside the circle. So this point's distance from 4 comma 3. So 4 comma 3 is, let's say, here. Clear? So we have to calculate a point's distance where it becomes the maximum. This distance should be maximum. So now tell me, maximum distance will be obviously something which is diametrically opposite to this point. Let's say if I just join this point, if I draw the normal, that will obviously pass from the center, and this diametrically opposite point will be at the maximum distance from 4 comma 3, right? So instead of calculating this point's coordinate then finding the distance, what I can do is I can only calculate the distance this, and rest distance I already know. This is the radius. What it is? It is 4. So why not let's calculate this distance. This point is given 4 comma 3. This is what? Origin. So this distance will be what? Root of 16 plus 9. What it is? 5. So the maximum value of this is what? 5 plus 4. What it is? 9. Done. This is our question. So I hope you enjoyed this question. It's a very easy question, right? Let's go ahead. Let's solve this. This is again one of the really good questions. I like this question because they try to misguide you. Now look at this. If 2 upon z, 1 upon 3 upon z2 is a purely imaginary number, what does that mean? Purely imaginary number. That means the argument is what? Argument of this number. Your cos of argument, cos of some angle should be like this, that you should get, your cos should be 0. When it can be 0? When it is multiple of either it is pi by 2 or what? Minus pi by 2. Only two options are there. So that means argument should be plus minus pi by 2. Then only we can have purely imaginary. Now what does that mean? If you just look at this, so these are the absolute value. Let's not worry about z1, z2. What it means? It means that argument of z1 minus argument of z2 is what? Difference between them is what? Pi by 2. So either you rotate z2 in anti-clockwise to get z1 direction, or you rotate this into in clockwise direction to get z1's direction. So this is for plus by pi by 2 and this is minus pi by 2 clockwise. Okay, so that's what it means. Now read this question. So what I understood is that z1 and z2 both are perpendicular to each other. This is what it means. Argument of z1 minus z2 अगर आप करो तो क्या रहा है? Plus minus pi by 2. So that means both are perpendicular to each other. Clear? Now tell me one thing. If z1 and z2 both are adjacent to each other, And when you try to draw the parallelogram where two sides are Z1 and Z2, adjacent sides, so one of the diagonals would be what? Z1 plus Z2, and another diagonal would be what? Z1 minus Z2, correct? Now, any parallelogram where two adjacent sides are having 90-degree angle, this parallelogram will be called what? Rectangle. Now tell me one thing. Rectangulars diagonals are always equal in magnitude, right? Correct. So that means mod of Z1 minus mod of Z2 is what? Equal to each other, right? So if I calculate this, the ratio, what will I get? 1 only, right? And that's what we need to find. That's it. We're done with the question. Okay, so one good aspect, with a really good thing is this, actually this 2 by 3 now, it won't make any difference. It could be 5 by 4, it could be 1 also, it could be anything, because this absolute value would not make any difference in argument. Argument is something else. Argument is being played with the sign. It does not need to, it does not vary upon the magnitude. It only varies upon the signs of real and imaginary parts. Okay, I hope everyone got this question. Let's move to another question. Okay, again, this is again very easy question. What it is? If this mod of Z1 plus Z2's whole square is equal to what? This. Then prove Z1 by Z2 is what? Purely imaginary. Okay. So let's start from left hand side. So this mod square is written as the multiplication of two conjugate numbers, right? So I can rewrite this as like this. Here, let's multiply Z1 into Z1 bar plus Z2 into Z2 bar plus Z2 into Z1 bar plus Z1 into Z2 bar. Now this is what? Mod of Z1 square plus this is what? Mod of Z2 square plus what it is? It seems as if this is the addition of two conjugate numbers. So when we have addition of two conjugate numbers, what do we get? Twice of real part of complex number. Now see this. Conjugate number can be written as what? Mod of Z2 square upon Z2, right? So let's write it this way. So twice of real part of Z1 by Z2 mod of Z2's whole square. Now this is again absolute value. It does not need to, it does not depend upon the, or it does not impact the argument actually. Correct. Now, if it is given to us that the left hand side is equal to what? This. If that is the case, so this will cancel out. What do we have? I'll have real part of Z1 by Z2 into mod of Z2 square is equal to what? 0. Correct. Now, as I told you, this is not related to argument. This is an absolute value. So real part of Z1 by Z2 is 0. What does that mean? That means Z1 and Z2 is what? It's purely imaginary. That's it. Get another question. I hope everyone understood this thing. It's a very easy question. Correct? Let's move ahead then. Oh, we have de Moivre's theorem. So I'll tell you the statement of de Moivre's theorem, what it is actually. So what de Moivre says is, if we have let's say n belongs to integers, so cos of theta plus iota sine of theta raised to n will be equal to cos of n theta plus iota sine of n theta. This is fun statement. You can prove it using either form very easily. Second statement says if n is not an integer, it belongs to rational number. Okay? When it belongs to rational number, then cos of theta plus I of iota sine of theta raised to n will have one value equals to cos of n theta plus iota sine of n theta. I hope this is clear with everyone. Why this is happening with the rational number? Because in rational numbers, when we can have a multiple of 2 pi's and all, right? So we can bring that 2 pi, the period also. Okay guys, so let's move ahead then. Now let's try to prove this question. Now what it is, so here one Euler form is written, another Euler, there is one polar form is written, another polar form multiplied like this. So if I want to convert this polar form into an Euler form, how will I write this? E raised to iota pi by 2 into e raised to iota pi by 2 square into e raised to iota pi by 2 cube, and it will go till infinity. This will be equal to what? E raised to iota pi by 2 plus pi by 2 square, and it will keep continue till pi by 2 cube. Correct? Now it seems like as if this is what? This is a GP till infinity terms. So till infinite terms, so if I want to calculate the summation of this GP, what will be? It will be A upon 1 minus R. So A is what? Pi by 2. What is common ratio here? Half. So what it will be? It will be e raised to iota pi. So this will be what? Cos of pi plus iota sine of pi. So cos of pi will be what? Minus 1. Iota sine pi is what? 0. This will be your answer. Minus 1. That's it. Very easy questions are there. It's just with every question what we are trying to do is we are trying to use properties, basic properties. That's it. Okay, let's move to our next question then. If z is equal to cos alpha plus iota sin alpha, it's a root of the equation. Okay, so there's one polynomial in nth degree, and this is e raised to, let's say, e raised to iota alpha. This is one of the solutions. Then we have to prove a1 sin alpha plus a2 sin 2 alpha, and it will keep continue till an sin n alpha. Now the very first idea which just hit my mind is I have to just take this and put it here, then I'll apply de Moivre's. So when I try to apply de Moivre's, also what do I get? A naught, this is n, so from here I'll get what? Sine of n alpha terms, from here sine of n minus 1 alpha terms, and that will be multiplied to what? A1, and this will be multiplied to A2. But in proof, this sine n alpha is multiplied with what? A raised to n, not a naught. So, and I am like, what to do now? Let's think about something. Do I need to multiply the entire polynomial equation with z raised to n? If I do that, then a naught will be multiplied to z raised to 2n. Then I will have sine of 2n alpha, but it is not given. Then what to do? Then I thought, yes, I can do one thing. Why not I multiply the entire polynomial, this polynomial with 1 upon Zn. Let's do this. When I try to divide this entire polynomial with z raised to n, what do I get? A naught plus a1 z minus 1 plus a2 z raised to minus 2, and this will continue till a n minus 1 z 1 minus n plus a n into z raised to minus n is equal to 0. Clear? Now when I put this z value here, I can apply de Moivre's. So what do I get? A naught plus a1 cos of minus alpha. So cos will absorb, whereas sine will not be able to absorb. So cos of 2 alpha minus iota sine of 2 alpha, and this will continue till a n minus 1. Cos of 1 minus n alpha. Again, I'll take minus common, so it will become what? N minus 1 alpha minus iota sine of n minus 1 alpha. And for the last term, an cos of n alpha minus iota sine of n alpha is equal to 0. Right? So 0 can be written as 0 plus iota 0. Now let's compare the real part and the imaginary part. When I compare the imaginary part, what do I get? Sine of alpha into a1 plus a2 into sine of 2 alpha, and this will keep continue till an into sine of n alpha. This is equal to 0. This is a proof for part A. For part B, it will be what? a0 plus a1 cos alpha plus a2 cos 2 alpha, and this will continue till an cos of n alpha. This is equal to 0, and this is proof for part B. Done. That's it. That's what we have to do. So again, as I told you in the beginning, yes, everything is very easy in complex numbers. You just need to peacefully read it and try to understand where to apply the geometric thing, where to apply the Euler form, because it gives you the hint. Okay, the question, the objective in the question will give you the hint what to do, what not to do. Clear? Let's do. Let's talk about cube root of unity. What is this cube root of unity? So let's do one thing. We'll study this cube root of unity tomorrow. So we'll have cube root of unity, a few more questions on the cube root of unity. So meanwhile, if anyone is having any doubt, you are always free to ask. You can just leave a comment. Hi Adya, how are you? You can leave a comment. Then we'll be talking about the geometry of complex numbers. Okay, so how can we represent circle, perpendicular bisector, straight line, other things, section formula. Okay, so we would be studying all these things tomorrow. Okay guys, so this is one more information I would like to share this with you, that I am running a fun day series. This is my fun day series. This fun day series is there on Unacademy application, and I conduct special classes. So those special classes are free of cost, and tomorrow there is a special class at 7 p.m. where we will be solving previous year questions on complex numbers. So I would suggest you guys to be there. You guys please come tomorrow, and we'll solve previous year questions on complex numbers. Then we can easily analyze whatever we have studied so far, whether that is enough for us to solve questions in IIT or not. Okay guys, so you guys can come tomorrow, and if you have liked my video, so I would request you guys to just like the video, subscribe the channel, and share the video with your friend so that he or she can also learn, and then you guys can just make a group and discuss your doubts. So more you discuss, more you learn. And those who have decided to join Unacademy Plus and Unacademy Iconic, they can use this code NK001. You will get 10% off, and you can just press the bell icon button so that you'll get the notification whenever I'll come online next time. So that's it from my end for today. So would love to see you tomorrow again on the same channel. Okay guys, so I'll take your leave. Bye bye, take care. So great Adya, you don't have any doubts. That's really good. Thank you.